question 1, we're given two industries, industry H, which is a high profit industry, and industry L, which is a low profit industry. If these two industries have similar costs, then what be true about prices in the two industries? We can assume that the prices in industry H is going to be higher than industry L, due to the fact that industry H is a high profit industry. So they should be able to charge a higher price for the same good, for the same cost. Part B, what is our answer imply about the value of the output in the two industries? If you have a higher price for your good, it means that it's going to be more valuable. So in this case, industry H goods are going to be more valuable than industry L goods. Part C, if labor and capital are moved from industry L to industry H, what is given up and what is gained? We give up quantity and profits of L to increase quantity and profits of H. So as a result, the profit rate is equalized, marginal value of resources is equalized, and total value of production is maximized. Due to the fact that the high profits in H will increase, which should cover up the loss of profits in L, which will maximize the value of production. So in part D, suppose that the prices in the two industries are identical. What must be true about the costs in the two industries? So inversely, if the prices are identical, then the cost of industry would have to be higher than industry H. If they are the same value and industry H is making higher profits than L, that means that the industry H are making their goods, the cost of their goods is much cheaper than industry L's. So what does that imply about the amounts of capital and labor required to produce one output in each industry? The cost of capital and labor to produce one input L would be higher than that of H. It's more expensive for L to make to make one quantity of good than H. Part F, if labor and capital were moved from L to H, are more in units of output lost in industry L or gained in industry H. More inputs would be gained in H, as the production costs are cheaper compared to L's. We would gain a higher profit in H, which would, like I said, cover up the loss of profit in L. So profit would be maximized. Question 2, we suppose that two industries, the pizza industry and the calzone industry, are equally risky, but the rates of return are 5 in pizza and 8 in calzone. Which way will capital flow? From the pizza industry to the calzone industry, or inversely? Since the rates of return are higher in the calzone industry, we can say that that's a high profit industry, while the pizza is a low profit industry. And usually, labor and capital will transfer from the low profit industry to the high profit industry, which will maximize profit.
Moving to question 3, we're trying to spread out our production across firms to maximize efficient output. In the first table, we're just adding up marginal costs to get total cost. In order for Smallco, the total costs we had to fill in are $100, $150, $210, $280, and $360. For BigCo, the values are $30, $40, $60, $90, $130, and $180. In Part B, we're going to begin to use those numbers to calculate productions. So to make 11 tons of steel, we're going to want the marginal costs to be equal, which happens at 4 tons from Smallco and 7 tons from BigCo, where marginal cost is $40. And to produce 5 tons of steel efficiently, we'll want 1 ton from Smallco and 4 from BigCo, where marginal cost is $10. For Part C, we just use those marginal costs to calculate price in a competitive industry. So the price is going to be $40 at 11 tons and $10 at 5 tons. If the government were to look at these firms from the outside, it looks like BigCo is the lower cost producing company. So intuitively, the government may want to just shut down the higher cost firm, which would be Smallco here. But this isn't actually where the market is going to be most efficient, as we'll see clearly in Part E. Because the invisible hand is going to be much more efficient than the government would be here, assuming there's no externalities. So imagining Smallco doesn't exist or is shut down by the government, the total cost of production for 7 tons of steel is $130, and each ton is going to cost $40. With Smallco in business, the total cost is $90, and the steel is going to sell for $20 per ton, quite a bit more efficient for everybody.
In question 4, we are reviewing the mechanism of the elimination principle. So given a theoretical industry X, what would happen to profits when demand rises? So demand increases, causing the profits to rise to above normal, because the price increases when demand increases. When that happens, do firms, workers, and capital tend to enter industry X or leave? Well, they'll enter industry X because the profit in the market is increased, So the industry has expanded, and that removes barriers for more firms to be able to enter. This increases the short-run supply in Industry X. As more firms enter, they'll be able to supply more. But in the long run, the increased number of firms increases competition, which brings price back down to average cost, which brings profit back down to normal profit. So now no one's making above normal anymore. This is basically a summary of the elimination principle, because both above normal and below normal profits will be eliminated in the long run, in this case above normal. Question 5. We're looking at how equalizing the marginal costs of each firm will lead to maximum total revenue in the industry. So we're looking at these two marginal cost functions, and we see that firm 1 generally has lower marginal costs than firm 2, but not at all quantities. So let's say the first unit in the industry has to be produced. Who should produce it? Well, firm 1, because it only costs them $6. It would cost firm 2 $9. But then let's look at the next unit. Should firm 1 produce that as well? No, because it costs them $10. But that would be the first unit for firm 2, and that's only $9. So you continue with this mentality, fill out the table. Firm 1 produces the first unit, then firm 2, then firm 1 produces the third unit, then firm 2 produces the fourth, firm 2 produces the fifth, firm 1 produces the sixth, firm 2 produces the seventh, and firm 1 produces the eighth. You just alternate by whichever one has the lowest marginal cost.
For question 6, we're investigating how the invisible hand property 2, which is the balance of industries, plays in the market. So we're giving the following 4 equations: demand, individual firm supply, market supply within firms, as well as individual firms' average cost. For part A, we're told that there are 24 firms in this industry. So using the QS equation, we have 0.5 N plus 0.1 NP, where P is the price and N is the number of firms, which is 24 in this case. To find the equilibrium, we'll have to equate Q demand to Q supply, and that gives us an equation of 100 minus 2 times price is equal to 12 plus 2.4 times price. And solving that equation of one unknown, that gives us a price of $20 and a total supply of 60. For each firm, we'll use the profit formula that we learned a few chapters back, and first working out the individual firm's supply as well as average cost. We know that the profit for each firm is going to be $7.05, and since all the firms are identical, they will have the same profit. The elimination principle tells us that in the long run, no matter you have an above normal profit or a below normal profit, the profits will be eliminated in the long run. And so since here we see that the price, which is $20, is bigger than the average cost, which is $17.18, more firms will enter the industry. Now for part B, something has changed. Now instead of 24 firms, we have 35 firms in this industry. We'll use the same set of formulas, but we will plug in different numbers for N. Here we worked out the equilibrium price is now equal to 15, so $5 lower than the previous. And at this price, we'll have a total supply of 70. Plugging those values in to acquire the quantity of supply for each firm and the average cost, we get a profit of minus $4.2 for each firm. That implies that the profit is negative. And since we see that the profit, which is $15, the price, which is $15, is smaller than the average cost, which is $17, more firms will exit the industry. Now for part C, the last part of this question, as well as the lab, we see that the elimination principle says that profit will be eliminated in the long run, which means we want to find the point where the average cost is equal to the price. If we plug the quantity of supply of each firm into the formula for average cost, we can equate average cost with the price. And then plugging in the supplies formula, we get that the price is going to be $17. And at $17, we have total quantity supply of 66, which gives the number of firm is equal to 30.